Hi everyone, I welcome you all into this Dell Boomi session. So in the last session, we talked about a couple of things, right? Uh, what all we covered in the last session, guys?
Find shapes.
Find changes shape,
Custom
right?
library.
Yes.
What does find changes shape do? It is used for CDC. What is CDC?
Create.
It is change data capture,
Change data.
right? What is the meaning of change data capture? It is also called as something like incremental load, right? So whenever you are working on an integration which involves the movement of data from one system to another, so many a times or in majority of the times you will not want to pull the full load from one system to another. You would want only the data which has got modified to be pulled. So in that case, what do you typically do? You make use of find changes shape, which keeps a track of the last execution and compares the data with that, and accordingly decides whether the control will go to add, update,
Update. Delete.
or delete, right? These are the three different branches we have, which comes out of this find changes shape, and it supports three profiles, which are those.
Flat files, XML, and database.
Very nice. It supports three types of profile, which are flat file, XML,
XML database.
right? So it does not support JSON and EDI types of profile. So this is one thing which we saw. What else did we discuss? We discussed about custom
Integration.
libraries,
Custom library.
isn't it? I mean, when I say custom libraries, I mean we try to establish a connectivity with the database. MySQL
MySQL
has
database.
has anybody tried to establish a connectivity with
Yes.
MySQL database?
Yes, I tried it.
Did it work?
Yeah, it worked.
Awesome. So did you get the jar from the internet?
Yeah, I got it. There is one website by jar download something.
Mm-hmm.
Yeah, by typing like MySQL that 25th version, I downloaded so I could get it from there.
Very nice. So all right. So we understood the steps that whenever we want to add custom libraries, there are two approaches. One is a manual approach, right? What do we do in the manual approach? We go to the installation directory, and in the installation directory you will find different folders, right? Isn't it? So there you will create a folder with the name userlib. Within userlib you will create a folder with the name database, and within the database you will place the driver. Driver is nothing but your jar, right? Corresponding to the database and its version. You will place that, and after that you can try to establish the connectivity. It should work. There is another way, which is via platform, right? I mean, when I say manual approach, again, here also you have to follow some steps, but then you don't need to have the access to the installation directory, right? You can manage this via platform also. So what do we do over here? We go to
Yeah.
user information and setup. Then where exactly do we go? Account
Account
libraries.
libraries.
In the account libraries, we kind of browse that jar. After that, we go to the build tab. In the build tab, we create a custom library component, right? It custom library in itself is a component, isn't it? Right? Then here we choose the library type. So there are three options: general, scripting, and connector, right? So in the connector, we will choose which connector? Database connector. Then we will select the jar, right? So there you will be able to see all the jars which are present in the account library. We'll select the jar. Once that is done, save it. Then you have to do package and deploy. Where do you deploy? We deploy to the environment
Where Atom is installed.
which is tagged to the atom that is required to be used while establishing the connectivity. Right? While establishing the connectivity, whichever atom we want to use, to whichever environment that atom is tagged, we deploy to that environment. After that, it's good if you just quickly restart your atom. It might sometimes work without restarting atom also, but good practice that you restart atom and then you start to establish a connectivity. It should work, right? So these are the two important things we talked about in the yesterday's sessions. Especially this custom library one is very, very important. Sometimes, you're working on the databases for which you do not have the out of the box jar. This should be helpful. All right. So in today's session, we'll talk about a couple of topics. We'll start with atom queues, right? Uh, so what happens is whenever you're working in the integration world, right? So there is something called as MOM, message oriented middleware, which is generally achieved with the help of queues or topics. Okay. So if you remember in initial sessions, we might have talked about the synchronous way of doing an integration. What is synchronous? What is asynchronous? What is one way? Anybody recollects? What is the meaning of synchronous, asynchronous, one way? No one? Synchronous means an integration is said to be synchronous when there is an immediate response for the request being sent. Request and response traverses via same channel. I must have given these definitions. Guys, these should be on your, especially people who are not working right now, the way you should prepare yourself is whatever is there in my notes, that has to be there on the top of your head. If that is not there, then that there is definitely problem in the way you're preparing. Okay. If you're just thinking that the circus which I'm doing every morning, if you will just see that circus and you will learn, that's not going to happen. Okay. You will have to become the part of the circus by participating in that, by doing hands-on, by looking at the notes, by making your own notes, and that is only the way you will be able to get into the market. Otherwise, there is no way, nobody will be able to help you. Believe me, mark my words, nothing is going to happen. After Dell Boomi, you will be learning some tool. Somebody will advise you to learn SAP. Somebody will advise you to learn DevOps. Somebody will advise you to learn any other tool. Okay. And I don't tell all these stories typically in my sessions, but in this batch, since we have more freshers, I'm telling you clearly, if you're not looking at things, it is not going to help you. Okay. Do not expect anybody to help you. It is only you who can help. This is such a demanding technology. I have tried to cover everything. You attend anybody different trainer session and our session, you will find a big difference. And if you're not able to remember all those things, then the problem is with you. Anybody, you will tell me that let's summarize everything. First of all, 30 days session cannot be summarized in 1 hour. Okay, that cannot ever happen. You have to start summarizing in your mind. You have to start going through those sessions. I can always summarize. I can tell, but I don't. I have been teaching online from 7 years. I have never done any one session where I'm summarizing the whole batch. Okay, you have to start summarizing. You have to start referring those videos. If you don't refer, nobody can help you. Rest is up to you. These all things I have covered here, and I have especially told that this is very, very important. The basics are very, very important. Anyhow, I'll keep on telling. People don't care, even I don't care. I have a next batch ready. An integration is said to be asynchronous when there is a delayed response for the request being sent, and request and response traverses via different channel. So what does that mean? Even you see in your real time, right? There you do perform a lot of activities. Some of them are synchronous and few of them are asynchronous, right? So let's say you're talking to someone over a call, right? Let's say you're talking to someone over a call, or for example, we are talking. though our communication should be synchronous, but I have seen a lot of times trainee making it either asynchronous or one way. For example, I'll ask some question, they will keep silent. So that becomes like one way communication. Ideally, if I ask a question, there has to be some kind of acknowledgement or there has to be some answer for that, which is synchronous. If you do an exchange of, thoughts over an email, that is kind of asynchronous. So how am I categorizing all these things? Because whenever first of all, there is a background noise constantly coming from someone's side, would request you to go on mute. Okay, I should not explicitly telling you this. Yeah, these are basic things you need to take care of. Anyhow, so what I'm saying is, when you send a request to some party, right, and you immediately expect a response or you immediately get a response, that is kind of a synchronous integration. Okay, or that is a synchronous use case. Asynchronous means when you send a request but you do not expect an immediate response. Okay, you just send a request, your job is done, you can continue some other activity, and whenever the response would be ready, you get notified via some mechanism, right? So let me give you an example. So you go to a shop or you go to a restaurant and you want to place an order. Let's say you want to place an order for food, right? Maybe for your dinner, right? And it takes 30 minutes for the preparation of the food. So in that case, after placing the order, can you go somewhere else? Can you go and finish off some of your other tasks, or else you tell them then that boss, like you go to, let's say, Domino's, right? Specifically in India, you go and place the order on the with the executive who will be there on their billing counter, right? And after that, do you need to stand over there? Do you need to wait over there, or you can go and chit chat with your families, and whenever it is ready, they will notify you by displaying your number on a digital board, isn't it? Yes. So
Yes.
let's say you go to some grocery shop, you ask for a milk packet, right? You go and you pay money, you ask for a milk packet. Typically, the moment you will pay, they will give you the milk packet, right? It is immediate, right? You will give them money, he will go and he will go to the fridge, he will open the fridge. I'm just trying to create that scenario so that you understand it and this sticks to your mind. Okay, the person will get the milk packet from the fridge, or the refrigerator, whatever it is, they will give it to you, right? So you kind of keep on waiting at their shop unless you get it, right? Maybe in even in that case, you can do a chit chat and all, that's fine. But typically the expectation is that this is going to be a transient integration. Okay, what is the meaning of transient? These all words I keep on telling, I don't know even people even give a damn about it. Transient means short lived. Transient means short lived. Short lived integrations typically will be asynchronous. Or else I can say you should choose only such cases to be synchronous which are transient. Transient means you send something request and you get an immediate response, right? You, let's say you pay the money that I need to have a 1 liter milk packet, and they give you the milk packet immediately. That is synchronous, right? Now another example I was giving is you go to Domino's, you pay the money, right? And after that they take time, right? Is it an immediate response or a delayed response?
Delayed response.
It's a
Delayed
delayed
response.
response, right? So whenever there is a delayed response, right, typically people would not want to wait for that response. Okay, usually they would not want, sometimes we don't have a choice. Okay, when they do not want to wait for the response, what they would expect is the party who is processing the request, right? So when you go to Domino's, you place a request, right, that I need two pizzas, veg or non-veg, whatever it is. So that is your request. Then they have a kitchen where they are processing that request, right? So what is your expectation? Your expectation typically is that whenever that request is processed and a response is generated, please notify me, right? That notification can be sent via an email, it can be sent via text message, it can be sent by displaying the things on a digital board, it can be sent by pushing something to some database, it can be sent by sending a push on your mobile phone. So you must have seen these days when I mean now it's a lockdown, but if you go to Domino's, your order is ready or about to be ready, they will send you a text message also. Even though you are sitting in the store, you are sitting in the restaurant, still they will send you a message that your order is about to be ready or it is ready. Please collect it or something like that, right? So the point I'm trying to say is whenever we have asynchronous integrations, okay, you might wonder why in the morning I'm all of a sudden talking about pizza and all that stuff. Because just to give an example so that you can correlate with the things. So whenever especially we are talking with the asynchronous, right? So asynchronous integrations have to be, so generally these are durable integrations. What is the meaning of durable? These are long running. Transient means short lived, and durable means long running. So this is not hard and fast rule. This is not always true that short lived will be always synchronous and a long running will be always asynchronous. There is no such hard and fast rule, but this is the convention which is followed in the industry. Okay. This is the convention which is followed across the industry, where the long running processes will be generally asynchronous processes. And what happens in the asynchronous process? The request is sent, and once it reaches to the server, server means who? The entity who will process the request, right? Then the requester part is done and it will not wait for the response. Okay. It's like, for example, you go to drop your son or daughter or maybe your younger brother to school. So if you go to drop them to the school, and let's say their school starts at 8 a.m. and ends at 2 p.m. So do you wait outside the school for them to come back? Or you just drop them the moment they enter the gate of the premises, you just leave back for your other work? Now, if someone doesn't have anything else to do and this is the only thing they have to do in their life, right? Then they might wait outside the gate of the school also, which might happen. But the usually the scenario would be that you would drop that person, right? Maybe you are going to drop your wife or husband to a office, right? So the moment they will enter into the premises of that place, you will leave from that place, right? And now let's say in the evening, whenever their office is done, they will give you a call. Yes, they will give you a call, right? So the point I'm trying to tell is the request is sent, and once it reaches to the server, then the requester or client part is done, right? Client job is done, and after that it will not wait for the response. It is server which needs to notify or send the response, which is also called as callback. I explained all these things. I really feel pity on the people who do not refer all these things. You will not realize the importance of all these things unless you work in real time. Anyhow, so the response in the asynchronous world is also called as callback. I gave an example also. So let's say I give you a call, right? And you're busy. You could not pick my call, right? So I sent a request that reached to you. Maybe you were busy. So does my life stop over there? It does not, right? I might take a session. I might continue with my work. I might do n number of activities. I might eat. Now, let's say you are busy with some meetings. You are busy with some n number of tasks. You are attending Dell Boomi sessions. Now your session is over. What do you want to typically do? Typically, you will do a callback, right? Yes, that is the meaning of callback. That's why we are using the terminology callback, right? So we are trying to do a callback. So that's why that response which is sent back, actually that is not actually called as response, but it is usually called as callback. So why I'm telling you all this stuff once again is because when we do the asynchronous integrations, right? So typically we need to do in a way, we need to do it in a way that it is reliable. We need to do it in a way that it is reliable. Reliable means, so let's say the requester sent the request, right? And let's say you process server starts processing it, and then let's say server in that, let's say there is some issue in the server. Let's say there is some issue in the server. Then also you should not lose that request, because in asynchronous what is happening is the requester, the moment the request gets submitted, it will always assume that my request has reached to the server, isn't it? The moment the request reaches to the server, right, requester is not going to wait anymore, right? After that, it is the responsibility of the server to process it and do a callback, right? Now server should design all such design patterns, or server should take care of all such scenarios in a way that even if something goes wrong with that request, if something goes wrong with the server also, then also we should not lose that request. Yes, then also we should not lose that request. And that's why I use the word reliable. Reliable means something you can bank upon, something you can trust upon, right? So for example, we keep our money in banks, right, instead of giving to our friends. Why do we do that? Because banks are more reliable than friends. And maybe some of us might have very good friends, they might not be depositing their money in banks, they might be depositing with their friends, because their friends are more reliable, right? You share your secrets with your life partners rather than sharing with your office colleagues, because they are, because your life partner is more reliable, right? So reliability is very, very important in the asynchronous integrations. And to achieve that reliability, right, we typically use some kind of temporary storage area. What does that mean? So what we typically do is we get a request, and we move it to a temporary storage area. And what is that temporary storage area called as? It is either called as a queue or a topic. It is called as a queue or topic. Now, behind the scenes, queue or topic will be either database or file system. Okay. See, whenever you want to store any information, so typically either you will store it in a database or a file system, right? So now you place your folders, your files, you use a file system, right? If you have something which is more secure, which is has to be stored in a more structured manner, you might go for a database, right? So the point I'm trying to say is queue or topic has got some persistent store. What is that persistent store? Persistent store means the place or the store which is used for storing something, right? So the persistent store is either database or file system, and queue is built on the top of that. So queue has a lot of out of the box functionalities which helps to make the whole integration reliable. Yes. So what do we do is not only reliable, it also helps in throttling. Anybody has an idea what is throttling? Throttling means regulating the number of requests received to the capacity of the server. Very, very important terminology. So now let me ask you a question. Let's say there is a server, there is a server which can handle Okay, no, let me not ask this way. Okay. So these days we are booking the railway tickets also online, right? I don't think any one of us is going to the, uh, booking center, standing in front of the windows and booking the tickets. But still, in a lot of villages or, suburban areas or rural areas, people still do that. They go to the, they go to the railway stations, they book their tickets. Sometimes they have to book the ticket in certain quotas, they have to get some discounts. So sometimes those kind of reservations do not happen online. They have to go and they have to get the sign of the some special authorized people, and then they have to book the ticket. And let's assume we are booking the ticket from, windows. So now tell me one thing, when you go for Tatkal, right? How many tickets can that person sitting on the window book at a time? Let's say there is one window. How many tickets can a person sitting on the window book at a time?
One.
One. Okay. One, if he drinks Complan or maybe Bonvita, he might do two, right? Or maybe three. But generally, a person can do only one ticket at a time, right? But how many people might be there to book the tickets, Tatkal tickets? You would see a long, huge rush right in the morning. I don't know how it is right now, but I remember when I was studying, there used to be a huge rush outside, that office wherein people used to stand in queues and all, right? So there is a huge rush, right? I hope you all will agree. You all might have gone some time to book the tickets. Okay, if you have not gone, you will go. I think all of us living in India must have experienced that. So how do we manage that whole traffic? Do all 20 people come at the same time, or how is it managed?
Queue.
Maintain queue.
So all these people stand in the queue, right? So what is happening if they will not stand in the queue? There will be a chaos, right? Right? There'll be people will fight that I need the ticket first and all that stuff, right? And what might happen is that person who is booking the ticket might get confused, right? That person might not understand anything, or the ticket may not ever get booked, right? Now, uh, to put things into a perspective, to make sure that things are properly aligned, what we typically do is we make sure that people stand in the queue. Now, what does queue do is queue works on first in, first out mechanism. Is it true? First in, first out mechanism. Yes. So what is the meaning of first in, first out? Who will come first will be served first, right? So the person who came first in the morning to book the tickets will be served first, right? So it also ensures that too much of traffic is not passed at the same time, right? Yes or no? So think it from the IT perspective also, right? Whatever is happening in your day-to-day life, right? Same thing is happening in your IT also. It is just matter of establishing that correlation. So even in the server cases, what happens is, let's say there is a big billion sale which is happening, right? Or I don't know, billion day sale or whatever it is. I don't know what is the name of that sale. So there might be a lot of traffic which might come in, right? So now for 5 days, they might want to increase the capacity of their servers. They might not want to do it. So generally in all such cases, right, when you do not know for big billion day, you can always anticipate that these are the 5 days when there'll be more traffic. But there are a lot of businesses where they do not know when there will be a surge. Surge means increase or in the number of requests. So what do they typically prefer is they prefer asynchronous integrations. What they will say is you come and submit your request. They store the request intermittently, okay, for some small time. They will store the request with the help of queues and topics, and then the messages will be pushed from the queues and topics, because What will these queues and topics do is these queues and topics will store the message somewhere in some persistent store. And what is that persistent store? Either database or file system. So that will make sure that your messages are not lost. And these messages, right? The messages which comes in the queues. So what do we store in the message queues? We store messages in the queue. So whenever we push something to the queue, it is called as messages. It is not called as payload, or I mean, you can call anything, but generally the right convention to call it is messages. So messages are stored in the queue, and these are removed from the queue only once it is successfully processed. Even if you do not want to remove it from even after successfully processing it, then also you can retain it in the queue. And that way you ensure that even though that there is something going to go wrong with the server which is going to pull the messages from the queue, still your messages will be there in the queue until and unless your queues gets an acknowledgement from the server that this message is good to be deleted. The queues will not delete that message. So that way what happens is, understand this, request comes from client, let's say comes from client, maybe through some app, then it goes to queue. So queue is like an intermediary storage area. From the queue it will go to the server, right? Server processes it, right? So now whatever messages which comes from here, right? Whatever messages which are coming from this app, these messages will come, and these messages will sit in where? It will sit in the queue. Then server, what it will do, server will not pull everything at a time. It will pull maybe one message, will process it, then that is over, it will pull the second message, third message, fourth message. So that way, and it is not necessary it will pull only one by one. If it has more capability, it can pull maybe three messages at a time. So sometimes like I don't know how many of you have taken the vaccine. So they will make you to sit in the queue once you go to the place, right? I recently took it. So I took it in a government place where they were doing it in a school, in a classroom. They were making all people to sit, and then they were asking five people to come at a time. So it is not necessary that always one person will be pulled. We might pull more people also depending on the capacity of the server. So the whole point I'm trying to explain you over here is this queues make sure that this data is stored securely, right? If it is directly going from app to server, and let's say server collapses, right, because of some reason, then you lose the data. Client will be always under the impression that your data was sent successfully, it is under processing, but the data is lost, right? And if your data is lost, client will raise a ticket after some days. So you will have lot of issues, right? Client will escalate that I paid the money, I raised the request, nothing is happening on me, my request, and the customer experience will not be good, because of which we always use queues to ensure that we have a reliability, to ensure that we can achieve throttling, right? This process of ensuring that you send the number of requests as per the capacity, right? That is called as throttling. And queues basically play a very vital role in achieving throttling. Okay, now you might ask me, what is the difference between queue and a topic? So queue is for point to point communication. What is the meaning of point to point? One message is read by one listener. Okay, so this queue has a message, and typically in the servers there will be something called as listener. What is the meaning of listener? Which will keep on listening for the messages from the queues, right? So what is the topic? Topic works on publish subscribe model, which is also called as broadcast model. Okay, or in other words, what I will say is, when one message is intended for a single recipient, When one message is intended for a single recipient, then we will prefer to use queues, right? So for example, you are having a private chat with your girlfriend, right? Would you want to broadcast that, or you would want to send to that person individually? You would want to send individually, definitely, right? So then queue is preferred, right? But now you're wishing happy new year to, all the connects. So in that case, would you want to send that one to one? I mean, one to one means, let's say you have 2000 contacts in your phone. Would you want that you should send 2000 messages separately, or you would want a facility wherein you send one message, but that is delivered to all 2000 people? You would want other way around, right? So when one message is intended for multiple recipients, then what do we go for? We'll prefer topic. Okay. Sometimes this is also called as multi-consumer queue. Okay. And this is which one? Single consumer queue. Any questions from anyone? This all is very, very important. When you start working in the real time, you will realize, whatever I'm talking over here, this all will make sense. This all is very, very important to know, right? I could directly start with the Dell Boomi atom queue also, but I personally believe you should have some context. You should have some basic idea about the topic. Otherwise, it will be just like mugging up things, right? So now there are different types of queues in the market, right? So one of the very famous queues we have is JMS queues. JMS queues are based on a Java framework called as Java Messaging Service. Okay. We have ActiveMQ. We have RabbitMQ. Yes. What else? So there are a lot of different queues like this. And similarly, Dell Boomi has its own proprietary queue. Dell Boomi has its own proprietary queue, which is also called as Atom queue. Okay. So now what happens is, even if you want to achieve this, if you want to achieve loose coupling, another important point why we use queues, loose coupling. Loose coupling means, what is the meaning of loose coupling?
Is it the same as decoupling?
Yes.
We make independent, which were dependent before, we make them independent. I'm talking about processes.
Very nice.
Yes.
So we will say loose coupling means like minimal dependency among two or more systems, processes, or whatever it is. Or we can say, in other words, it is like making two things independent of each other, one and the same thing. So now what happens is, let's say you receive a request, right? So there is a source application which fires a request that comes to Boomi, and maybe from Boomi it goes to SAP, right? So now what happens is, let's say in Boomi, to process that request, it will take, let's say, 30 minutes. Okay, let's assume that there are a lot of operations you have to do. There are a lot of transformations you have to do. So what we will do is, typically, if that source application is sending the request, right? So what we'll do is, we will break down that in Boomi into two parts. Okay. The first part, we can break it into multiple parts, but primarily on a high level, first two parts. First part, receive the request and puts it into some kind of queue. Okay. And sends the acknowledgement back. to the caller. Okay, understand this. You are not sending the response. All you are sending is the acknowledgement to confirm to the caller or to the client or to the source application that boss, your request is received and it is under processing. So what we are doing is there are two parts in the Boomi. First part is receiving the request and puts it into some kind of queue. Queue is kind of a temporary storage area, right? It may be a queue or it may be a topic depending on the intention. What are we trying to achieve? If we want to broadcast, we might put it into a queue. And if we want to kind of do a one-to-one communication, then we might put it into a queue, right? And then we send the acknowledgement back to the caller so that at least source application is not waiting for those 30 minutes. Okay, so this first part might take hardly few seconds and your source application will get to know, okay, my request has been received. And whenever the processing would be done, I'll somehow get notified, right? Then there'll be a second part. What would this second part do? Second part would either listen or read the message from the queue. Now, reading the message from the queue and listen the message from the queue are two different things. Listen operation gets triggered on its own the moment new messages are available in the queue. Okay. Listen, or some people, this is sometimes also called as a polling operation. Okay, so what happens in this? The moment message is available in the queue, okay, the listener will read it immediately on its own. Okay, whereas read operation is required to be triggered explicitly. So it will not get triggered on its own. You need to explicitly trigger it. So depending on the business requirement, you can do it. So in the second part, we will either read or listen the message from the queue and process it. So what we are doing here is how we are achieving the loose coupling. So we don't want this source application to be dependent on the Boomi's processing time, right? We want to decouple that source application with the Boomi's process time. So what we do is we receive the request, we kind of store it in some intermediary place, and we return some kind of acknowledgement so that source application is not completely dependent on the processing time of Boomi. And even Boomi as a tool, if it is taking 30 minutes, right? So Boomi should not end up or Boomi should not stop receiving the request after a certain time, right? So let's say Boomi can process only 10 requests at a time, but source application is firing 1,000 requests. So Boomi should not error out. So what this first part will do is first part will keep on receiving the request and it will put it into a queue, right? And second part might take more time, which is fine, but still we will have messages sitting in the queue, right? So when you go to a doctor's place to get a consultation, what happens, right? So there is a person, maybe a compounder, or these days, they have got some executives sitting outside, and they will ask your basic details. They will ask you to pay the money, right? And they will give you a receipt. So it is kind of an acknowledgement that your request is received. But is your request processed? No, right? Your request hasn't been processed. Who is going to process your request? Doctor is going to process your request. But the moment you get receipt, then you get an acknowledgement that you will be getting a consultation from the doctor. So you sit in a queue. If you see there is an half an hour, you can go outside, you can have some snacks, or you can come outside depending on your health, right? If you're going for a regular checkup, if you're in an emergency, definitely you need to wait. But the point I'm trying to convey over here is, so we want to decouple things in real time so that the source party, and other target parties sometimes do not become completely dependent on each other. And at the same time, we want to have a mechanism in place which is reliable, which is secure, which enables the loose coupling, right? And that's why we use all these queues and topics. right? So Boomi has got its own queues called as Boomi Atom queue, which is pretty simple to use, right? This whole story I just wanted to share because I feel this is important to know. And after that, this is pretty simple. So what do we do over here is we go to a folder with the name Sumit. We'll start with the new component. We'll start with the process, and let's say I'll name it as Atom queue. I start with the no data type, save. So now let's say this is the process which will be fired by the source application. When we start using APIs, you will get to know that so far whatever processes we developed, those were more like what? Scheduled ones, right? Which needs either those are scheduled or that is explicitly required to be triggered. Yes. Just give me a minute. So what I'm saying is, so far whatever processes we build, right, those were either required to be triggered explicitly or we were required to be scheduled. But then there can be business requirements where we want them to be such that these can be automatically triggered whenever any event gets fired in some source application. What does that mean? So whenever, let's say, an order gets generated in my Salesforce, I want that order to be immediately processed and passed to ERP, and ERP returns some order number which I want to send back to the Salesforce, right? So what I'm saying is there may be scenarios where, let's say, Salesforce receives the order. What is Salesforce? I'm talking about CRM. Okay. Then it goes to Boomi. Boomi sends it to ERP, let's say something like SAP. And in SAP, an order number is generated. And that order number, we need to return it to the Salesforce. So these are like real-time integrations. Real-time integrations means an event is getting fired in the Salesforce. That event needs to be passed on to the Boomi. Boomi will do the necessary transformations, will pass it on to the ERP and receive the and return the order number back. So when all these kind of integration has to happen, we cannot schedule this. Okay, if we want this to happen immediately, we will mostly use APIs, which is our next topic, right? If it is near real time, if it is not exactly real time, but near real time, for all near real time integrations, we can make use of queues also. Okay, so queues makes the thing loosely coupled. So you receive the order, put it into a queue, Boomi will process it, send to a SAP, SAP will return some response, and maybe what Boomi will do is Boomi might send an email that this is your order number, or Boomi what it will do is it will go and update that back into the Salesforce so that somewhere on the UI you can see, okay, this is your order number. Okay, but so sometimes what happens is internally things are getting processed asynchronously, but customer will get an experience or customer will feel that is happening synchronously. That is also done sometimes, that customer will be feeling that it is happening synchronously, but internally those are not synchronous, those might be asynchronous internally, right? So that depends on how do we design things. So we'll talk about APIs, but let's understand what does this atom queue mean. So for example, you have some message, let's quickly cover this, some employee data. Yep. Now what do we do next? You go to atom queue connector. So there are two actions, get or send. So right now I want to push the message to the queue. You can make connection. So when you make connection, it is asking to create some queue. So I click on plus. So let's say I'm naming it as a test queue. So can you see some queue type? Point to point, publish, subscribe. Now, do you understand what is the difference between these two?
Yes.
Yes. So in Boomi, they have not given anything like topic, but the moment we are using publish subscribe, this is like a topic, right? When we are using point to point, this is like a single consumer queue. Done, done. Operation. Now here you can select the batch size, that how many messages you want to send in a chunk, right? 1, 2, 3, 4, 5. That's up to you. That's fine. Okay, hit OK. After that, you can add a stop shape if you want. It's pretty straightforward. Okay, everything looks successful. You push the message to the queue, right? You don't think anything going to the stop ship because the send operation, once you push the message to the queue, it is not returning any document back. So how can you see your messages? You can go to atom management, select the atom. There is something called as queue management. So this is a nice interface where you can see what is happening with the queue. So can you see your queue type? And there is one message which is residing in the queue. Is there anyone reading the message from the queue right now? No, right?
No.
So still the message is there in the queue. So queues have a capability to hold these messages. So now I want to see, I have three options on this gear icon. We can view the message, we can clear the message, we can delete this queue itself. So we'll say view message. We'll click on this. This is some unique ID, and here how many documents do we have? One, right?
Yeah.
View document details. Okay, this is your formatted document, isn't it? Nice. So your message is still there in the queue. Now I can have another process. Let's say or maybe in the same process, I can go to atom queue connector once again. This time I will choose the operation as get. Okay, that's fine. The connection, I will reuse the connection. Operation. So here you see there are some timeout settings, that how many number of document. There is some background noise coming from someone. Please go on mute. Okay, so there is some timeout settings. Timeout setting means how much time you would wait. I think for processing. So once you basically read the messages, right? For how much time you will wait for that read operation to perform. So maybe it is in milliseconds. So 10,000 milliseconds means 10 seconds. It will wait for 10 seconds. You can check the documentation also. So if you, let's say you're not sure, we can read out the documentation. I'm not 100% sure if this is about the read timeout or connection time. There are different timeouts. Okay, so we can go here. Where is the documentation for this one?
In case of a non-cloud atom, does the queue messages get saved on the computer's disk?
Yes.
Okay.
Okay, everything is internally getting saved on your machine only. If you're using a local atom. Okay, so here you can see the documentation sets the amount of time that the operation will wait to receive the documents. Yeah, it is kind of a read timeout only. It will, the default is 10,000. The following has special meanings. The operation 0 will not wait and receive only the documents in the single message if one is immediately available. So you can read these things out. If it is -1, the operation will wait an infinite amount of time to receive the documents, right? So the point I'm trying to say is you can read out these settings. There are a lot of settings. So here you can, there is something called as a dead letter queue also. Okay, this dead letter queue is nothing but a error queue. Okay, so typically what happens is when you read the messages from the queue and let's say something goes errored out, right? So typically it will go back to the queue, and this kind of cycle continues 2 or 3 times. Okay, and after that the messages will go back to the dead letter queue, and you can see your messages in the dead letter queue. So that's why I said that queues are more reliable because your messages are not lost. So if your message is not getting processed successfully because of some reason, it might still be there, but it might go to the dead letter queue. So dead letter queue is like an error queue. So whenever you create a queue, a corresponding to that another queue gets created, that is dead letter queue. I will explain again. So here we created a test queue, right? Now we are going to read the message. Let's say we read the message and after that there is some error. Okay, if you are not doing anything, if you're throwing an error, the tendency of this message is that it will go back and sit into the queue again. It will go back to the queue again. Then maybe again you are trying to read and again it is getting failed. So I am not 100% sure on whatever. So it depends on the number of retries we configured. And after that, what is going to happen is this message, which is continuously getting erring out, it will go into another queue, dead letter queue. So dead letter queue you don't need to create it explicitly. It will automatically created for your original queue. So there will be a dead letter queue for this, where you will have all your failed messages. Now, if you feel that that message is failing because of some data issue, right? You can fix that data and you can bring it back to your normal queue also. Or maybe that was failing because there was some issue with your process. You fix that issue and then you can bring it back to the normal queue also. So now I'm trying to perform a read operation. And when I'm saying a read operation is explicitly required to be triggered, right? Read operation is explicitly required to be triggered. That's why I have to explicitly go and trigger it, right? This is not a listen operation. Listen operation is a separate operation which is not required to be explicitly triggered. So here I'm performing a read operation from the queue. So when I perform a read operation in the queue, from the queue, you would see the message which was pushed to the queue. This is the message which we push to the queue. Now if you go to the atom management, you go here, you go to the queue management. So there are no messages over here, right? Yes, there are no messages over here. So that means the message has been successfully read. Now, if you there is one more thing, which is about listening the messages from the queue. I'll start with a new process. So whenever you want to start with the listen operation, that has to be configured in the start shape. Okay, this is a note. Whenever we want to configure any listener, how do we do that? We need to do it in the start shape itself. You cannot have listeners configured after the start shape. Okay, so we go here, we will look for atom queue. Here is the one. Do you have a listen operation also? Yes. You'll choose the connection, hit plus. So here you can consume from the dead letter queue maximum concurrent executions, which means in parallel you can want to read 5 threads. So maximum concurrent executions means like how many threads you have, right? So for example, think of it like you are going on a national highway, right? So there'll be a toll gate. Yes. So there will be 7-8 parallel toll gates, right? You can route your vehicle through any of those toll gates, right? So it means maximum concurrent execution means there are 5 different toll gates processing parallelly, right? So here this maximum concurrent execution means 5 threads. So that parallel executions are achieved with the help of concept of threads, right? So you can always take an example of toll gate, right? In toll gate, what we do is we have 5 different parallel executions happening. Similarly, here we can decide if we want 5 parallel executions to happen, we can consume 5. If we want one at a time, we can do one, right? So what this will do is this you cannot test from here because listener processes cannot be tested from here. This needs to be deployed, but then this will implicitly get triggered the moment there is a fresh message in the queue. This is not required to be explicitly triggered. This implicitly gets triggered. All your listener processes will implicitly get triggered. You don't need to schedule them. You don't need to manually go and trigger them. They will wait for some kind of event to happen. Okay, they will keep on listening for that event. The moment that event occurs, right, this will implicitly start. It does not mean that it will, automatically start on its own. But what I'm trying to say is that they are always waiting for some kind of event to happen. The moment that event gets fired, they will listen for that event and will get triggered. Somebody definitely needs to fire that event, right? But then after that, this listener does not need any kind of explicit uh, trigger. After that, once that event happens, this will automatically go and listen to that event. Okay, so just another example we took, right? First we pushed to the queue and then we wanted to read, means we had to explicitly go and call this process to go and read. But in the case of, for example, I do this. Okay, let me do this so that you understand. So you push the message to the queue, right? Now, if you want to read it, you have to go and do this. But in case of listener, that's not required. So what I'm trying to say is there is some confirm recommendation. I'll do it. There is a stop shape. I'll just quickly add a stop shape. That's all. I'll say create package component. I hope you guys are aware about all these steps. I won't repeat. Deploy environment review done. Okay, it's done. It is deployed. Now you go straight to your process reporting. Can you see automatically one instance got created, which is this one, event listener. That's what I was telling, that it waits on event. For this particular process, the condition to get fired is it should find an event in the queue. Okay, it was listening for that event. It found that message. It implicitly got triggered. We don't need to go and manually trigger it. Right? Let me show you once again. Let me open a duplicate tab. I don't know why the session got expired. Okay, I'll come to the build tab. We'll go to this process. We'll push one more message into the queue. So the moment we push the message to the queue, this process functioning is over, right? After that, it is another process which is doing the processing, right? So that is called as loose coupling, right? So we broke down the whole solution into two different processes. First process is just making sure that it is going to some place which is secure, which is reliable, which can store the data permanently or maybe intermittently depending on your requirement. And then you have a second process which is pulling it from the queue. Can you see the second process pulling from the queue? Automatically that is getting fired because your listener listens for the events, and the moment that event is there, it will go and read that automatically. Any questions from anyone?
If we make a process and I'm sending a request to a server, the server does not send me back the response I want, but it does send me an acknowledgement. In this case, will the process be synchronous? Because acknowledgement is also kind of response, right?
I mean, see, it actually, this Dell Boomi typically does not develop a true asynchronous process. You can say that, yes, that you are breaking down that into two different transactions. You can consider that as synchronous in a way that you are sending an acknowledgement. Okay. Your whole solution is kind of asynchronous, but yeah, if you see
Yes.
a true definition, yes, it is that transaction, if you want to see between the caller and your process, yes, that is synchronous, because the moment you go into the response section and if you see anything coming back, that is synchronous. Typically, in case of asynchronous, you should, I mean, a true asynchronous is something where you do not see anything coming back. Okay, but Boomi does not allow you. If you, I'm like, I used to work on a tool called as Oracle SOA. If you develop asynchronous processes over there, you would not see anything coming in the response section. Okay, it that gets accepted, your request gets accepted, and it will not return any kind of acknowledgement as such. Even if it happens behind the scene, maybe at the network level, but as a, you will not see anything in the response. Your response, I mean, you do not have even a provision to accept the response. And after that, whatever happens in a different thread. Okay, this has more to do with the threads also. So this whole processing is happening in one thread. Once this is done, your next process is using a different thread. So we do not typically want to hold the threads for the long. If you will hold the threads for the long, then you might run out short of resources, because because whatever processing you're doing, right? So there is a thread pool. So that thread pool, it's like something, you have, let's say you are arranging a wedding party, right? You will have different waiters or different help who is basically serving the snacks, food to the guest, right? So what you would want to, so what you do is, so that is like a thread pool, right? So you would not want to typically hold one thread pool. So let's say one guest hold one waiter with him or her, then there'll be a, maybe we have 50 waiters, right? But we have 500 guests. If each waiter gets stuck to one guest, then there might be few guests who will not be getting any kind of thing, right? So what we typically try to do is, we typically try to not to hold the threads for long time with one processing. And that's why we typically do it, so that our threads keep on getting released, and at least we should continue getting the request, and we should continue putting them into a queue, so that after that, even though it is taking long, but we should have messages sitting in the queue, so that even the source is sending me more traffic, I will be able to accommodate that in my process. I mean, I will be able to accommodate that, because I will just let them to sit in the queue.
And we can use the thread pool in the later stage after we give the data from the queue to the
Actually, thread pool will get used in the both the stages, right? Thread pool will get, so thread pool is the total number of threads you have got. Okay, that is more at the atom level. Okay, so you have some n number of threads with you, but then within the thread pool also there will be some kind of segregations. Okay, some of the thread pools will be only out of the thread pool, some threads will be only used for, let's say, listen operation, some thread will be used for other things. So at least you will have some threads which can always continuously keep on pushing the message on the queue. Okay, and again from those thread pool only you can use, so that, so threads will, how thread pool will work is, you have, let's say, 100 threads. One thread will go do some task. Once that task is done, that thread will kind of come back to the thread pool. So your other process can use threads from the thread pool. This process will keep on, it will also use the threads from that thread pool only, but it's not that all the threads will automatically go to one process only. So typically the way this is architectured is that we do not dedicate all the threads to one process. So we kind of have some segregations, so that we don't end up doing only one kind of operations with the threads which are present in the thread pool.
Okay. This load balancing is done by Boomi's side, right? By itself.
So you can call it as a load balancing, but the better word will be throttling. Okay. Yeah, and that is internally taken care.
Okay.
So guys, that's pretty much I have. We'll just wind it up. We'll meet like after this, we'll just have sessions on APIs, which I'll do on weekends. Okay. I would plan one session where I will consolidate everything. Okay. Like couple of people requested. So I want to kind of value their request. I will console. I mean, but I want to give you some time. Go through all the sessions, get some idea, because even if I'll try to kind of summarize everything, that will only make sense once you know, right, what is being summarized. So you take some time, brush up all the things which we have covered, and then we'll plan a briefing session where I will try to summarize all the things, and we'll try to give you some tricks and tips which you need to follow to crack any kind of client interview, or to do better in your jobs. So that's pretty much, guys. Let's catch up tomorrow at 7:30 p.m. I'll be sharing the invite across, right? Let's discuss about APIs over there.
Thank you, sir.